Welcome to this explainer. Look, if you've been experimenting with AI coding tools lately, you've probably felt that exact same frustration we all have. You start strong and then you just hit a wall where the code completely devolves into an unmaintainable mess. Well, today, we're going to fix that. We are fundamentally changing your workflow, and we're going to explore how old school software engineering fundamentals are actually the absolute secret to unlocking the true power of AI agents. Okay, let's just quickly run through our roadmap for today. We have 6 key steps. First, the AI paradox. 2, rules of the game. 3, the day shift. 4, tracer bullets. 5, the night shift. And finally, number 6, deep modules. Let's jump right in. Starting off with section 1, the AI paradox, old school fundamentals. And we are kicking things off with a pretty massive irony regarding this whole new AI coding paradigm. So everyone kind of assumes we need these entirely new, groundbreaking mental models to work with artificial intelligence, right? But the truth is actually buried in the past. There's this great point from educator and developer Matt Pocock. And the crucial takeaway is that 20-year-old software practices, literally the stuff you'd find in classic books like The Pragmatic Programmer, are exactly what you need to manage modern AI. The rules we use to keep human developers focused and productive, those are precisely the constraints we need to apply to large language models. The best practices haven't changed at all. They've just found a brand new audience. Moving right along to section 2, rules of the game, LLM constraints. Because before we actually build anything, we absolutely have to establish the physical limitations of these models. If you don't understand these boundaries, you're literally just going to be fighting the AI instead of guiding it. Notice how rapidly an AI's capability degrades as you work. When you start a fresh session, your AI is highly capable. It's squarely in what we call the smart zone. But as you add tokens, it's kind of like adding teams to a football league. The complexity scales quadratically. By the time you hit around 100,000 tokens, the AI just completely enters the dumb zone. It gets completely overwhelmed and starts making incredibly stupid decisions. So to succeed, we absolutely must keep our tasks small enough to stay right there in that smart zone. And to stay in that smart zone, we have to talk about how the AI remembers. Developers love to compact conversation history, right? Essentially summarizing a massive long chat to save space. Actually, scratch that. Compacting context is bad. It creates this confusing sediment. You really want your AI to behave like the main character from the movie Memento, just constantly clearing its memory to stay squarely in the smart zone. Every single time you finish a task, wipe the slate clean and go right back to your base system prompt. Which brings us to section 3, the day shift. Human in the loop planning. This is where your primary job comes in. This is where you, the human in the loop, step up to do the real heavy lifting of alignment and planning. There's a very strict sequence of steps you have to take to build alignment with your AI before a single line of code is ever written. We start with your raw idea, maybe it's a brief from a client, then we move into this really aggressive phase called the grill session to hash out the details. From there, you reach a shared design concept, and finally you output a rock-solid destination document, like a product requirements document or PRD. Now, you might be wondering, how do we avoid the trap of just generating absolute, useless specs to code slop? It is super tempting to skip the heavy planning. You just write a quick spec, toss it to the AI, and let it vibe code the whole app. But let's be real, that fails miserably. Why? Because you completely lose your grip on the actual codebase. You stop shaping the battleground. If you don't actually understand the deep constraints of what you're building together, you just end up with an unmaintainable nightmare. So to prevent that, you prompt the AI with what we call the grill me skill. Instead of eagerly generating a flawed plan, you actively force the AI to ruthlessly interrogate you. It asks you questions one by one about literally every assumption. Things like, hey, should these new user points be retroactive? Or where exactly does this UI live? You do this until you both reach a crystal clear shared design concept. Only after this intense alignment session do you let the AI summarize the whole shebang into a PRD. Okay, section 4, tracer bullets. Translating the PRD. Let's see how all this planning actually translates into actionable tasks.
A PRD is really just a destination, right? Now we need to define the journey. To stop the AI from just coding blindly into the void, you need to break the PRD down using tracer bullets. This is a classic engineering concept. Think of an anti-aircraft gunner firing into the pitch-black night sky. Normal bullets are invisible. You have no idea if you're hitting the target. But tracer bullets literally glow, giving you instant visual feedback on your aim. We need to structure our AI's tasks to provide that exact same instant, glowing feedback on the whole stack.
Left to its own devices, AI naturally wants to code in horizontal slices. It'll happily build out an entire massive database schema, then move to the API, and then finally the front end. But if the AI builds horizontally, it gets absolutely zero feedback until the very end of the project. Vertical slices, on the other hand, building a super thin feature from the database through the API all the way up to the UI, allow you to test an integrated system almost immediately. So we must prompt the AI to split our PRD into vertically sliced tasks. Once we have those distinct tasks mapped out, say on a Kanban board, we are officially ready for the next phase.
Section 5, the night shift, AFK execution. With our Kanban board of vertical slices totally ready to go, we hand things over to the night shift.
This is where you literally step away and the agents take over. We call this the Ralph loop, where parallelized agents work completely AFK, away from keyboard, sequentially knocking out tasks. Because our tasks are cleanly separated on that Kanban board, multiple agents can actually grab independent tickets at the exact same time. They read the ticket, they implement the vertical slice, they review their own work in a fresh, cleared context smart zone, and then they generate a pull request. You literally wake up to code that is completely ready for human QA. It's like magic. But wait, how does the AI actually know it's writing good code while you're asleep? While test-driven development, or TDD, is absolutely essential here. Those automated feedback loops are the only way the AI knows it's actually succeeding in the dark. Without tests, your AI is coding completely blind. By forcing the agent to write a failing test first, the red phase, before it implements the solution, the green phase, and then cleaning it up in the refactor phase, we prevent the AI from cheating. It essentially instruments its own feedback loop before it writes a single drop of actual logic. And finally, Section 6, Deep Modules, the foundation. We really have to look at the environment where your AI agents actually live, your codebase architecture itself. Because, simply put, bad codebases make bad agents, period. This whole concept comes from John Ousterhut's philosophy of software design. If you have shallow modules, lots of tiny files with heavily tangled dependencies, your AI will just produce absolute garbage because it can't figure out where to draw clear test boundaries. But deep modules, they give the AI a clear, testable gray box where it can safely operate. A deep module has a super simple interface on the outside, but complex logic hidden on the inside. You design the interface, and you let the AI handle the complex, deep implementation inside that easily testable box. So the ultimate ceiling of your AI's capability is directly dictated by your architecture and your feedback loops. You simply cannot automate messy architecture. So it's time to put these old-school engineering fundamentals to work. I want you to think about your current codebase right now. Are you building deep modules? Are you giving your AI tracer bullets to test its aim? Or are you just letting it generate absolute slop in the dark? Because the future of AI coding isn't about ignoring the code. It's about structuring it perfectly so your agents can truly thrive. Thanks so much for joining me on this explainer. See you next time.